Hi, welcome to Unit 1 Practice. I've already gone over the key points with you in class and also the 4 examples, or 3 examples I should say. Here's a student practice, and I'm going to go through this step by step so that you have a better understanding and that you're prepared for our exam. You will hear my stylus hit the screen a bunch. I'm sorry, I can't stop that, but I will be going through these problems step by step in case you need any support. So let's start with number 1. Solve each equation, check your solution to verify it is correct. So first off, what I'm going to do in order to solve this equation is I'm going to draw the river according to our 6 steps of solving. So I'm just going to take a line and it's going to go all the way through the middle like so. Next up, step 2, according to the 6 steps of solving, means I need to check to see if I can distribute. I can here on the left. The 5 needs to be distributed, and this -3 needs to be distributed. So once we do that, 5 times 3x is 15x. 5 times positive 4 is 20. And then I'm bringing down minus 2x. This will equal 7x comes down. -3 times -2x is positive 6x. And -3 times positive 11 is -33. After you distribute, I'm going to check to see if I can combine like terms. I can combine 15x and -2x to make 13x, and then a 20 comes down. On the right side, I can combine 7x and positive 6x to make 13x, and I'm going to bring down a -33. After you combine like terms, I'm going to use inverse operations to isolate x. I want to get x on the same side. So what that means is here on the, here I notice that I have 13x on both sides, and I can subtract this 13x on the right hand side to eliminate it, and that means I need to do the same. But notice whenever I do this, I'm left with 20 is equal to -33. So this multi-step equation is actually a special solution equation, because here I see that I've ended up with a false statement. This is false. 20 does not equal -33. So what that means is that this is a contradiction and there are no solutions. Let's look at number 2. After I draw the river, I'm going to distribute where I can. I can distribute this -1 and this 1/2. When I do, this is 7x comes down. -1 times 3x is -3x. -1 times 5 is -5. And then I'm going to bring down the -8. 1/2 times 8x is 4x. 1/2 times 20 is 10. And I'll bring down -7x plus 5. Next, we're going to combine like terms. 7x minus 3x is 4x, and -5 and -8 make -13. 4x and -7x make -3x, and 10 and 5 make 15. Now my goal here is to move all of my x's to the left side and all of my constants to the right side. in order to achieve that goal, I have a negative 3x on the right that I need to move to the left, so I'm going to add 3x to both sides. 4x and 3x makes 7x. Bring down negative 13. This eliminated the x's on the right side and leaves me with 15. Now, all of my x's are on the left side, but all of my constants are not on the right. That means that I can add 13 to both sides, and I'm left with 7x equals 28 because I eliminated the constants on the left side. For the final step, now that I have all of the variables on the left and all of the constants on the right, I'm going to divide by the coefficient of x, which is 7, and that leaves me with that x is equal to 28 divided by 7, which is 4. So this is the answer that I'm going to verify is correct. In order to verify that is correct, what you should do is at the step where you simplify the equation, or in the very beginning of the equation, in one of those two steps, you should verify that 4 is the correct answer. I'm going to verify at this step right here, because I'm pretty confident in that first step of distributing and then combining like terms. So what that means is I'm going to substitute x. I'm going to substitute the 4 because x equals 4 in every x of that equation. This would be 4x minus 13. Let me copy this actually over here. So 4x minus 13, and I'm checking this side as well. And that they're going to be equal. So I'll write the equal sign. Now I'm going to plug in 4 for the x's. Or I'm going to substitute 4. So this is going to say 4 times 4 now, minus 13. And on the right hand side, negative 3 times 4, plus 15. 4 times 4 is 16. 16 take away 13 is 3. Negative 3 times 4 is negative 12, and negative 12 plus 15 is 3. This is a true statement, so that means that x equals 4 is the solution. Number 3. Given a right triangle, the first angle is 10 degrees more than 3 times the degree measure of the second angle, and the third angle is the right angle. What is the angle measurement of the first angle? So, there's a lot going on here. I know that we're given a right triangle. I know a right triangle has a 90-degree angle in it. So it looks something like this. And I know one of the angles has to be 90 degrees. Let's call this angle, oh, it said here, the third angle is the right angle. So let's call this angle 3. I'll put the 3 inside. And I know that angle 3 is equal to 90 degrees. I know that there have to be 2 other angles. So let's call this angle 1, and let's call this angle 2. I know angle 1, according to the problem, says that it's 10 degrees more than 3 times the degree measure of the second angle. So what that just told us is that 3 times the degree of the second angle, so 3 times that degree, and 10 more will get you the measure of the first angle. And then I know whatever angle 2 is going to be what angle 2 is. So, and I don't know what that is, so let's call that x. Now, what do we know about all 3 of these angles? I know that since this is a triangle, that all 3 angles of a triangle always add up to 180 degrees. So what I could say is that angle 1 plus angle 2 plus angle 3 need to add up to be 180. I know that angle 1 is equal to, let me get my pointer, here we go. I know that angle 1 here can be found here. So I know that angle 1 is 3 times angle 2 plus 10. So I'm going to substitute. So I'm replacing angle 1. I know what that measure is. I know it's 3 times whatever angle 2 is plus 10. I know that angle 2 here can be found here. So angle 2 is equal to x, right? That was the angle that we said we just don't know anything about. So I'm going to replace angle 2 with x now. So plus x. And then finally, I know that angle 3 is the right angle, and the right angle always measures 90 degrees. So I can replace this 3 with 90 degrees. And all of this will add up to 180. Well, wait, I can substitute even more. Remember we substituted an x for angle 2? But there's also an angle 2 here. So that means that I can go inside where it says 3 times angle 2. I can erase the angle 2 part, because we know angle 2 is what? Angle 2 is x. So I can put an x inside of there. So that means that we just substituted twice. And on this substitution, and now we can start combining like terms, because I see x's and I see constants and among other things. So from here, this says 3 times x is 3x plus 10 plus x plus 90 equals 180. If we combine like terms, 3x and x make 4x, and 10 and 90 make 100. I have my variables on the left, but in order to get my constants on the right, I'll take away 100 on both sides, and I have 4x equals 80. I'm going to copy this so I can do the last step. In order to isolate x, if I know that 4x is equal to 80, then I can divide by the coefficient of x. If I have 4 x's, then that means that each x is worth 20. So x has a value of 20. Now I can use that to find the measurement of the first angle. That's what the question's asking. So since x is equal to 20, if I'm looking at this relationship here, right, remember that is equivalent to angle 1 based on this information over here. So I know angle 1 is 3 times x plus 10. Well, 3 times x, I know x we just found out is 20. So this is saying 3 times 20, which is 60, and then add 10 to that. So 60 plus 10 makes 70, and that's going to be the measurement of angle 1. So here, angle 1 is 70 degrees. Well, remember angle 2 is worth x, and I know x we just found is 20. So angle 2 is 20 degrees. And I know the problem told me that angle 3 is 90 degrees. And if you double check, 70 plus 20 is 90, and 90 plus 90 makes 180. So the math works out. And I know that the problem wanted to know angle 1, so the angle 1 is 70. So I would bubble in 70 in my griddable. There we go. Let's look at problem 4, special solutions. So we did have a special solution in number 1, but we will have some more here in 4, 5, and 6. It says, what is the solution to the equation here? So we would solve this just like we did earlier, and I would first draw the river so I can separate my left and right sides. And then we are going to start to distribute and then combine like terms. So if we distribute the 3, we get 6b plus 27. Bring down the negative 2b plus 1. On the right side, if we distribute 4, we get 4b plus 28. Combining like terms, I get negative 4b. Sorry, that's a positive 4b. And 27 and 1 make 28. Equals 4b plus 28. Oh, well, what do you notice? Here, let me make that a little bit prettier. Here we see that we have 4b plus 28 and we have 4b plus 28. They're identical. That means that the coefficients of the variables are the same and the constants are the same. Whenever both the left and the right side are exactly the same, we call this an identity. An identity means that for every value of b, for every value that you can think of, doesn't matter what number it is, whether it's 6, 8, 10, 12, whatever, or negative a billion, since everything is the same on both sides, you'll always end up with a true equation. You'll always end up with a true statement. Since you'll always end up with a true statement, we say that there are infinitely many solutions. There's too many of them, so we call that infinite. And when there's infinitely many solutions, it's because the solution is all real numbers. No matter what number you can think of, it works. So the solution is, and what I would ask you to bubble in or write down, is all real numbers. Let's look at 5. I'm going to draw the river and look to distribute. 9 times 4 and 9 times negative 2 makes 36 minus 18x. Bring down minus 3. We're distributing the negative 6 here, so this is going to be 4. Negative 6 times 3x is negative 18x, and negative 6 times negative 5 is positive 30. If we combine like terms, I get negative 18x plus 33 equals negative 18x plus 34. Notice, this time around, we see that the coefficients of the variable are the same. That has to be true. But the constants are not the same. So when the coefficients are exactly the same, but the constants are not the same, This means that we've run into a contradiction. A contradiction means that no matter what value you plug in for your variable, any value you can think of, we'll always end up with a false statement in the end that would say that 33 is equal to 34, right? That's a contradiction. So we would say that there are no solutions to this equation. The only reason we have no solution is because the coefficients were the same and the constants were different on both sides of the equal sign. So I just described everything for you for part 6. It says, describe the conditions for an equation to have infinitely many solutions. Describe the conditions for an equation to have no solutions. I'll briefly go over those one more time. I'm just going to talk about it rather than write it all out. In order for you to have infinitely many solutions, the coefficients of your variable have to be the same, and the constants of your equation need to be the same. When both sides of the equation look exactly the same, it's called an identity, which means that the solution will be all real numbers. In order for an equation to have no solutions, the coefficients of your variable need to be the same, but the constants of your equation are different. That's called a contradiction, and a contradiction means that your equation has no solution. 7. Solve and graph each inequality. In order to solve each inequality, I'm first going to write and separate the inequalities. So for this first inequality, it's this left side that says negative 2 is less than negative 4x plus 6. Now, I'm going to write the left side of the inequality, which says negative 4x plus 6 is less than or equal to 10. I'm going to solve both of these inequalities. For the first one, in order to isolate x, I'm going to take away 6 from both sides. This leaves me with all of my constants on the left and my variables on the right. Now I'm going to divide by negative 4. I'm writing exclamation point. That's because since I'm dividing by a negative, my inequality sign reverses direction. Negative 8 divided by negative 4 is 2, and I have x on the right side. So this says that 2 is greater than x, or x is less than 2. Let's go over here on the right. I'm going to follow the same steps. First, I'm going to take away negative 6. Whoops, that's 4. There we go. And then I'm going to divide by negative 4. Again, I'm dividing by a negative, so that means my inequality sign reverses direction. And then 4 divided by negative 4 is negative 1. So then I'm going to put these two inequalities together to make my final solution. My final solution is, one of them says that x is greater than negative 1, and the other says that x is less than 2. So to combine them, I'm going to say that x is greater than or equal to negative 1, and x is less than 2. You see I put the low number on the left side, and I put the high number on the right side. And the inequality signs are pointing to the left, and they stayed with the number that they were paired with. So my answer is that x is in between -1 and 2. To say that, let's put 0 here, -1 here, which means 2 is somewhere out here. X is greater than or equal to -1 and less than 2. So there's my solution graphed. Let's take a look at 8. 8 is already separated for us because it's an OR compound inequality. We can solve directly from here. I'm going to take away 3 on both sides. And then I'm going to divide by the coefficient of b. Since I'm dividing by a negative, I'm going to reverse the inequality sign, and I'm left with that b is greater than or equal to 4. On the right side, it's different, but I'm going to still isolate b, which means to add 10 on both sides to get that 3b is less than or equal to -35. Sorry, that's 15. Then I'm going to isolate b. So b is less than or equal to -5. Notice I did not reverse the inequality sign because I didn't divide or multiply by a negative. So let's read what these say. This says, the left one says b is greater than or equal to 4. So I need to make sure I have 4. And I'm going to be greater than or equal to that 4. Let's say that 0 is going to be here. The other inequality says that b is less than or equal to -5, which is about right here. I'm less than or equal to it, so the closed dot means or equal to, and in order to be less than -5, I'm going to shade to the left. So the solutions to this compound inequality are that b can be any number as long as it's less than or equal to 5 or greater than or equal to 4. Any number that satisfies one of those inequalities is a good value for b. Last one, number 9. An unknown substance has a freezing point of 120 degrees and a boiling point of 280 degrees. The substance is currently at a temperature of 105, but it's being heated at a rate of 5 degrees per minute. The scientist wants to heat the substance long enough for it to become a liquid, but not so long enough that it becomes a gas. Let M stands for minutes heated. So, I know that the scientist wants to heat the substance long enough for it to become a liquid. So, it wants to become a liquid, but not so much that it's a gas. So it has to be in between some temperatures, right? If the freezing point's 120, which means that's when it's going to become a solid, and the boiling point is 280, when it's going to become a gas, that means that we want to be above the 120 mark, but below 280. So I want to be above 120 degrees, but I want to be lower than 280. Now, I know that the substance is already at 105, and it's increasing at 5 degrees per minute. So, for every minute, it's increasing by 5. So that means I can say 5m. If it's already at 105, then I'm starting at 105, so that's plus 105. So The middle part represents my substance temperature. And this is saying that I want my substance's temperature to be less than 280, but greater than 120. And now I can solve this inequality. So I'm going to rewrite them. 120 is less than 5m plus 105. And my other one, that I know 5m plus 105 needs to be less than 280. Let's solve those. If I take away 105 on both sides, I'm left with 15 as less than 5m. If I divide it by 5 on both sides, then I see that I have 3 as less than m. So that's one side. Over on the other, take away 105, just like before. 280 minus 105 is 175. If I divide by 15, m is 31. Sorry, I don't think it's 31. Let me double check my math. 5 can go into 17 3 times. It's 35. That's what it is. So m is less than 35. So I know that my final solution, if I combine those, since m is greater than 3 and less than 35. So here's 3, here's 35 already out there, and now the m is in between 3 and 35, not including 35. Sorry, I made a mistake there. Let me erase that closed dot, and I need to put an open dot because it does not include 35. So m is in between 3 and 35. Well, what does that mean? Remember, m stands for minutes heated. Let me mark that over here. M is minutes heated. So I know that the minutes heated need to be in between 3 and 35. Why? So that it's in a state that it's going to be liquid because it's above the freezing point but below the boiling point. So here I could say the scientists should heat the substance between 3 to 35. Actually, let me write that in words. Should heat the substance between 3 to 35 minutes to keep it as a liquid. If he doesn't heat it for at least 3 minutes, we know that it'll never reach 120 and it'll be frozen still. But if he heats it more than 35 minutes, we know he's going to heat it too much and it's going to go past the boiling point, which then means it's going to start turning into a gas. So that's what all that means. Alright everyone, this was my Unit 1 practice. If you made it through the end of this video, or you had a problem with one of the solutions that I came up with, or that you just needed more clarification on a step, please make sure that you reach out to me via Teams, or you text me or call me on my phone. So, this is Mr. Mannion, our Unit 1 practice. You'll be ready for tomorrow. I know it. Bye.